Hi, this is Maria from Unstructured, and in this video I'm going to give you a quick TLDR on what an MCP server is and show you how to build a quick MCP server with Unstructured API and connect it to Claude Desktop. Let's go. What is MCP? MCP is Model Context Protocol, and it is an open protocol that standardizes how applications provide context to LLMs. But we already have other ways of providing context to LLMs. So one notable example is RAG, or Retrieval Augmented Generation. This is when you have your knowledge base that's stored into some vector store or database, and you retrieve documents relevant to a query to give to your LLM so that it could provide a better answer to a user question. And another example is agents. At the core of an agent is an LLM that can plan its actions to solve a problem, but also the model has access to tools. For example, models are not great at math, so you can build a calculator tool and make it accessible to your LLM agent. So when it's faced with a math problem, it can invoke the tool and solve the problem. And tools can be anything you want. For instance, you can convert your document retrieval from your vector store into a tool and make it accessible to an LLM. And now you've just built a basic agentic RAG. So what's different with MCP? The easiest way to think of MCP is that it allows you to build tools for LLM-powered applications and LLM agents you don't develop. MCP follows a client-server architecture. So on one side, you have multiple existing tools that integrate MCP clients in them. This can be Claude Desktop or Cursor, Windsurf, and other applications. On the other hand, you can build an MCP server, which is a lightweight program that will expose some functionality to any of these clients. By building an MCP server, you're building a tool that any LLM agent that supports the protocol can now use. And the tool you build can do anything you want, call any API you want, perform any actions you want. And you will be able to control it by talking in natural language to Claude Desktop or to Cascade in Windsurf, for example. So the possibilities of what you can build are endless, and your tool is automatically compatible with all MCP clients. And the best part, it's actually super easy to get started with building MCP servers. Let me show you. For this example, I'm going to build a simple MCP server that will allow Claude Desktop to read any file that I want it to read. So right now, if you can upload files to Claude Desktop, you can click here. But if I wanted to read this email file that I have in this folder, I cannot upload it because Claude Desktop does not support email files. However, Unstructured can process 60 plus different file types, which is a lot more than what Claude Desktop supports. So I can build a simple tool that can help me here. I can build a simple MCP server that will partition documents with Unstructured through the API, and then we'll get the results, the extracted text from those documents to Claude Desktop. For data processing with Unstructured API, I'm going to need the API key, and I'm going to need to set it in the environment variable. So this is a template. I'm obviously not showing you my actual key here, but this is what your .env file should look like. MCP servers can provide three main types of capabilities. You can configure resources, which are file-like data that can be read by clients. You can build two functions that can be called from an LLM or by the LLM. And you can configure pre-written prompt templates that can help users accomplish specific tasks. We only need to build a tool, and we can do this by converting a Python function into a tool. To build the core of this MCP server, we're going to use FastMCP. It's an abstraction that significantly simplifies MCP server implementation. So with FastMCP, we just need to apply a special decorator to a Python function that we want to be the tool. So let me walk you through this implementation. Here I have a couple of helper functions that just load environment variables and convert JSON to text. The reason for the second function is that unstructured returns the results of data processing as a JSON file, and it contains both the content, the text of the original file, as well as a ton of metadata. For this application, I just want to throw away all of the metadata. I just need the text. So this is why I need this helper function. And then I have this main document processing function that will be my tool in the MCP server. And as you can see, all I needed to do was to add this decorator, mcp.tool, and fastMCP will take care of the rest. The function itself is very straightforward. If the file exists and if we support it, then we're going to send it to the partition endpoint of the unstructured API. We're going to use auto strategy to partition the file. This strategy will pick the best partitioning strategy based on the file type and in some cases also based on the content of the pages. We'll write the result into a local JSON file, and then we'll just strip the JSON file of all of the metadata, leaving just text that we're going to give to the LLM client, the MCP client. In this case, it's going to be Claude Desktop. To run an MCP server, all you need to do is to add mcp.run, and there it is. Now, all we need to do is let Claude Desktop know that this tool is available. To do so, let's go to terminal. You need to find, on Mac, you need to find this directory. So library application support Claude. And then in this directory, if you don't have the configuration file for Claude Desktop yet, you need to create it. Otherwise, I already have it, so I'm just going to open it. You need Claude Desktop config JSON file. And in this configuration file, you need to list all the MCP servers that you want Claude Desktop to pick up. So in my case, I'm going to call it Unstructured MCP, and this is a doc processor .py file that is my MCP server. Once you list your MCP servers in this file and you save it, you need to restart Claude Desktop, and this tool will be available. Let's go and see it. You should be able to see your MCP server available as a tool here. See one MCP tool available. We can confirm that. And now let's grab the path to that file and ask Claude Desktop to do something about it, like summarizing it, for example. And as you can see, Claude identified that this is a path to a file, and then it can use unstructured processing tool to extract content of that file. And there we have an answer. Now this obviously can be further improved, but this way you can already, with a very small function, allow Claude Desktop to read any type of file that unstructured supports. And that's it. Have fun building MCP servers.